Puzzles 2017.
Hey guys, my name is Rene Freingruber and I'm working at Recon side, and today I will talk a little bit about carrier control. So this is a firewall. I will go quickly to it. So carrier control are these devices here. It's a firewall containing stuff like IPS, antivirus, VPN, and so on. And it's used by about 60,000 companies. So before I was doing this research, I didn't really know this company. But since then, I often see that customer projects, also their mail server is very often used. And you can also make a showdown query. I think about 30,000 companies are using, for example, the mail server. So you can really attack many companies with this attack. I will present here today just one attack vector. We basically found two different attack vectors. The first one is just about exploiting web stuff, so cross-site scripting, which you can use to bypass cross-site request forgery to then make some file upload to make command injection. But I will skip this for today and just talk about the second attack vector, which is more about memory corruption exploitation. So in the second attack vector, I'm going to exploit the CSRF check to execute my own actions on this device and then exploit a PHP unserialized vulnerability there. So I will just skip here the first attack vector. The first attack vector was just the possibility to upload here this shell script, and the shell script will just be executed with root privileges. And of course, we found really lots of cross-site scripting vulnerabilities, and it was always they fix just one and don't fix the remote code execution, and we're just fixing the cross-site scripting stuff. So I think we found 7 times new cross-site scripting. This is how the second attack vector is working. Let me just. You see here. We are attacking an internal firewall, so there's no port open from the outside, so I cannot directly attack this firewall. Instead, I'm attacking some victim. The victim goes to my website, so I, as attacker, return some malicious HTML or JavaScript code, which will force the victim to send my malicious attack payload to this firewall. And you see here I have some problems which I have to solve. So first of all, I have to know at which internal IP address the firewall is stored. And the second problem is, of course, I cannot read the response because of the same origin policy. That means I have to write my exploit completely blind. So see here, are the problems. As already mentioned, the internal IP address, and another problem is also that what do I do if the victim is currently not logged in? So the first attack vector with the web stuff was just working against administrators, and for the second attack vector, I just wanted to make it work against every user because it's not so common that someone is logged in the firewall. And of course, we also have to bypass the cross-site scripting filters or CSRF protection. To solve the first problem, we can use some kind of trick. I think it's already a well-known trick. What you can do is we can just try to load the carry logo from all possible IP addresses. So I'm just iterating over possible IP addresses and try to load it. And because of same origin policy, I cannot read the response. But what I can do is I can install a JavaScript handler on onload and on error. So I can then detect if onload is successful. I can detect if carry is running on this IP address or not. So this way I can identify carry control in your internal network. And I can use the same trick to determine if I'm currently logged in as a user, because what I can do is I can just try to load your internal user image, because if you're logged in, I will get some user image back. If you're not logged in, the on-error method will be called. And this way I can also brute force your internal login via cross-site request forgery, because their main login is not protected via cross-site request forgery. So just as soon as you're logged in, there are cross-site request forgery protections. So this way, even if you're not logged in, I can start some brute force attack against your internal system from the internet. And the last problem are the cross-site request forgery, cross-site scripting protections. So in the first attack, we were using cross-site scripting to bypass the cross-site request forgery checks. In these cases, we were lucky because they were doing some strange stuff with Space64, and using this, we were able to bypass all the protections. But for the second attack vector, I wanted to directly bypass the cross-site request forgery. So the second attack vector is using two PHP scripts. This is the first PHP script. So basically with the first script you can set the data, and with the second PHP script you can do some stuff with this data. And this is a really funny flaw here. So basically there are two flaws in this code. I will give you a quick time to read this code. Sorry. Yeah. So basically what they were doing, they tried to get the cross-site request forgery token from the user. So they say either get me the get or the post parameter. And the problem is, in JavaScript this would work. But this is PHP code. That means that this OR here is a binary OR. That means that the result is not the get or the post parameter. The result is 0 or 1. So now they have to store the number 1 or 0 in posted hash. And now they're making here a loose comparison between the real cross-site request forgery token, this is a string, and the integer here. That means because they don't make here the type checking, the string will be converted to an integer. That means they always check 1 against 1, and that means you always bypass this check. This was the first cross-site request forgery bypass. The second one contained a different bypass. So here, they're doing the stuff correctly. They just get here the get parameter. But the problem is, in the first one, they made here the check, is the posted hash empty or some condition. And here, they make the same check, is the hash empty and some condition. That means as soon as you set it to any value, you can again basically bypass the cross-site request forgery check. That means this allows me to execute any action on these two PHP scripts, and they basically contain everything what you need as attacker. So we have remote code execution, we have the unserialized vulnerability, we have the possibility to make heap spraying, we also have other cross-site scripting to bypass same origin policy, and of course there's also a third script which can be used to bypass address-based randomization because the PHP script is leaking C pointers to the user. So for the second attack vector, I'm using the fact that they're using a very old PHP binary. It's more than 6 years old, and they're calling unserialize on user-supplied input. And I hope everyone knows that unserialize is a very bad function. It was abused many times. For example, Stefan Esser found many bugs in it. I think currently some guys at Black Hat and DEF CON talking about PHP 7 unserialized exploitation. I think the Pegasus malware was abusing unserialize in the kernel and so on. So you can very easily exploit this kind of stuff here. So you see here, this is the code which we try to attack. What we can do is we can set the variable name, the value, and then we can set any session variable to any value, which is very powerful. And after that, the second script just takes the last displayed session variable and calls unserialize on it. So what I'm doing is I just call setPHP, set the last displayed variable to some malicious input, and then just call unserialize on it and exploit it. So I'm using here the C4E 2014-3514 vulnerability. It was found by Stefan Esser, and I was just starting by analyzing it on my own system. So this is just how unserialize is working. So for example, if you have an integer 1 to 3 and call serialize on it, you will get the serialized version of it. So it's just saying here I for the data type integer, then double dot 1 to 3. Or for example, if you have a double, it just says double, then the value, or S for string, then the length is 4, then the actual string. And you can also make some more complex stuff like arrays. So you have here A for array, 3 for, because we have 3 elements stored in this array. And it's always, the first value here is always the key or the index. In this case, it's index 0, this index 0 here. And then we have integer 1 to 3 and so on. And if you have a look at the source code of PHP, you also see that we can add references. So, for example, if we pass this array here, it says array 3. So what PHP internally will do is it will add a pointer inside some reference table, which is pointing here to the first element, to the array. Then for the next element, so keys are not stored in this reference table, and so on. Until we come to some reference that says reference 3, that means go to the reference table, to the third index, take this pointer here, and replace this reference here with this value. So if you try to execute it, you will see, you will just print 4, 5, 6, because it's referenced. And another very important concept are how variables are stored in PHP. So this is just for the old PHP version. With PHP 7, I think it changed a little bit. But the important fact here is that they store the value and the type. So depending on the type, for example, if the type is string or integer or object, they interpret the value in a different kind. So you also see here that this is a union. And see here. So if it's, for example, a string, it will be interpreted as a string pointer and a length. And you also see here that this data structure contains a reference count. That means we are counting the references. So for example, if I'm holding 3 pointers to it, the reference count should be 3. As soon as the reference count becomes 0, the memory should be freed. And nearly at least the older unauthorized vulnerabilities work like this. You have some data, you have a reference to this data, and then you add some strange code in between which will free this data. So that means that this data here will be freed, but we still have a reference. And the main problem here is that this reference here is does not increment the reference count. So it does not have an influence on the reference count. So we just have to find here some code which will free the data. Then we can use the reference here to access the free data. So like every simple use of the free buck. And this C4E number here is abusing the SPL object storage. So as the name says, SPL object storage is used to store objects. You can see it here. We are storing, for example, the alpha, so an object with a length of 5 called alpha, and a beta object here. And it will just calculate a hash on it. So let's say the alpha hash will be 1, 2, 3, 4. That means we are storing inside this hash table at index 1, 2, 3, 4 this alpha object. So that means the reference count of alpha will be 1. The same for the beta object. So let's say the hash is 888, so it's pointing there. Reference count is also 1. The problem occurs as soon as we try to find 2 objects which have the same hash. So for example, if I now have the beta object having the same hash, I will override this pointer here. So now there's no pointer anymore to the alpha object. That means alpha will be freed from memory. But I still have a reference to it from the reference table, because this reference here is not counting the reference count, which is, I think, the main problem, because all unauthorized vulnerabilities work like this, and if they would just increment here the reference count, they would have prevented many unauthorized vulnerabilities. So the question now is, can we find 2 objects which have the same hash? And the first answer is no, you cannot, because the input for the hash also contains the object number. So if I have 2 objects, the object number will be 1 and 2, so they will result in different hashes. But we can abuse here another problem, a type confusion bug. So this, for example, is another vulnerability. It was also found by Stefan Esser. You see here, if I'm calling PHP info, it will just go to the PHP self variable, interpret this variable as string, and just dump it. And this macro here is always dumping it as a string. It does not check the type. So it's basically a type confusion attack. So as you see here, they are completely ignoring here the type field and just getting the value here. You see it in this macro definition. Just interpret this stuff here always as a string. And that means you can attack this kind of stuff if you just set this to an integer, because the type is not checked, and for example then you can read from any location. But this attack here doesn't have a real attack scenario because you typically cannot change the PHP code. But we can use the same idea for our exploit, because the input for this hash calculation is using this macro here. It just says take the object, because we should just store objects in this object storage and interpret it always as an object. But it does not verify if this object here is really an object. So what I can do is, I can just store inside this object storage a double value or an integer or a string, and just use this or set this double value in a kind that it results in the same input for the hash calculation. So you see this here. I'm using here an object of std class. This has this input. So basically it's the second object. This is the pointer to the function pointers. You also see here 5 is the type. And then I have here this double value, and I have chosen this double value in a very specific way. You see it here, so that this value here will be exactly the same, even if this type will be another 2 because it's a double value. But only these 2 first keywords will be used as input for the hash calculation. That means that the second double value will remove this object STD class from the memory. So the memory will be freed. I will just go there. So this double value will free this object value from memory. And then I'm just allocating here another string. It's of length 15. 15 because the data structure has a length of 16. The set value data structure, and to strings is 1 added for the null termination. That means why I'm using here a string of length 15. And now I can have full control over this memory. So now this reference is pointing to this freed memory of STD class, and I have allocated this stuff over it. So now I can just say, okay, data type is 5 for string. That means I can just read from the memory. Or I change the data type to object. That means I can set the function pointers to any address. That means I can get full code execution. We have here just two problems. The first one is address-space randomization. That means my data is at random locations. So I was working quite a long time to find a good way to come around this. So one possibility would be to use this PHP script here, which is just leaking heap and stack pointers. But the problem is because of same origin policy, you cannot read it. So I then decided to just make a very dumb idea, just to make heap spraying. So as I showed you already, I can set any session variable to any value. Perfect. To any value. That means I'm just saying session variable x1 is this 8 megabyte value, session variable x2 is this 8 megabyte value, and so on until the complete heap is completely filled. So that my data is everywhere. So you see here it takes about 24 seconds. And after that, just go quickly over it. You see here I have full control over 2 locations in memory. So in this case, I was just using A0, A0, 0, and B0, B0, B0. But you can use here any location which is sprayed with your code. The second problem is data execution prevention. That means that your own data will not be marked as executable. I'm just doing here the standard technique with return data programming. So the main binary, it's 26 megabyte big and is not position independent. That means we can just get, for example, the address of malloc, then calculate the base address to mprotect and just call mprotect. So for example, this is the ROP chain which I'm using here to obtain the address of mprotect, and then I'm just calling mprotect to make my own code executable. I will just show you now a quick demo. So you see here, you can just go to the website, download all the stuff as a virtual machine, and you also see here the internal IP address where this is running. Then the victim goes to my website. In this case, I'm adding here debug output, but typically the victim would not see that anything is ongoing here. So you see here the debug mode can be disabled so that nobody is seeing anything. But in this case, I'm just adding it so that you can see what's going on. So now I'm trying to load to identify the carrier control system in the internal network. So I'm trying to load from different IP addresses carrier controls. You see here, from this IP address, it was not able to load. But from this IP address, I was able to load the carrier control image, and from this not. So this way, I know at which IP address carrier control is running. So you also see this is the same IP address here. So see from all these IP addresses, it was not possible to load the image. So the next step is I identify if I'm currently logged in. So you see here, this is the user image which I try to load. You see it's not loaded, that means the user is not logged in. And here this field is the cross-site triggers forgery attack, where I'm trying to brute force the internal IP address via the victim browser. So now I was able to log in. So the next step is to make the heap spraying. So I'm now doing here the heap spraying, where I allocate lots of stuff in the memory to bypass address-space randomization. Just go back here. So now the heap spraying finished. The next step is to set the unserialized data and then just call unserialize on it with the cross-site triggers forgery bypasses. And as soon as this finishes, I just obtain a reverse root shell on my system. And of course, the web server is also running as root, so you then can further attack the network, the internal network. You can sniff the VPN gateway because everything is going over it. You can dump the passwords or as you like. And yeah, you see here I'm running as root. And yeah, of course, you can also dump the password hashes and so on. Just here, a very quick word about the vendor response. They just said that the web service running as root is not considered as a vulnerability, and the first remote code execution from the web stuff is not considered as a vulnerability. They will not fix it. And also the way how they fixed the second vulnerability was just they didn't update their PHP binary. They were just saying, okay, we removed the unserialize. Also very important, the two scripts which I was abusing were not referenced by any other script on the system, so I don't really have any idea where they're there. Maybe it's old file or someone placed them there. And so it's still PHP 5.2.13, so you just have to find another bug in PHP and can still exploit it. For example, you can just run EFL or something like that against PHP, against this 6-year-old version. And yeah, thanks.